Okay, so is my screen visible?
Yes, yes, yes.
Okay, great. So let's start. Okay. So all right. So welcome to the seventh session. I guess today is the seventh week. I think today is the discussion for seventh week content. So this course is basic electrical circuits, and the instructor is Dr. Ankush Sharma. He is a professor in the Department of Electrical Engineering at IIT Kanpur. Myself, I am the tutor of this course, and my name is Mayank Karupa. I am also a PhD student and a PMRF scholar. I am from the Department of Electrical Engineering at IIT Kanpur. Alright. So in this week you learnt about circuit analysis using Laplace transforms, right? So in the last week you learnt about Laplace transforms, how to find them, how to take inverse Laplace transform and all. You also studied about the properties of Laplace transforms. And so this week you have learnt about how to use Laplace transforms in order to solve circuits, right? So circuit problems can become immensely easy if you use Laplace transforms. It is very useful in circuit analysis. Okay. Yeah. So this week I will be solving some problems, some sample problems based on application of Laplace transforms. So I hope you will enjoy and learn something here. Fine. So in this week, I'll quickly summarize the topics. So you learned about Laplace transform of circuit elements. You learned about Laplace transform of common circuit elements like inductors, capacitors, resistor, voltage source, and all, current source, and all. After that, you went on to the concept of transfer function. Right. So you studied about transfer function, how to find them, and what they are. Then you also learned about convolution integrals. So it's a very important topic. It's a very important concept, convolution. So you learned about it, and then you learned about how to. So basically, convolution integral as can be interpreted graphically, right? So that interpretation was talked about by the instructor. So there was so convolution integral. Graphical approach of convolution integral was taught to you. After that, you the last of the week you learnt about network synthesis and network stability. So you saw that a network is stable if for for the bounded inputs, for all bounded inputs, you have bounded outputs. Basically, this is called bounded input, bounded output stability, in which if your input to the system is bounded, that means the input is not like something infinite. If the input is bounded, then the output should also be within some range. It should be bounded, and that is called as stable system. So you learned about bounded input, bounded
Uh,
output, stable. Yeah, hello.
when output is bounded for any system, then input is any signal, no, sir?
Yeah, so input can be anything, as but just you have to ensure that input should not be unbounded. You should not apply like infinite voltage at some node, and then check what is the voltage at the output. That is not
Means
right.
for means for any signal bound output is bounded, sir.
For any signal, output is bounded as long as the signal which you are feeding to the system is also bounded. So
Yes.
input should not be unbounded. Input should not become input should not go infinity or and all. It should be bounded, and for those inputs, for all those inputs which are bounded, you should have bounded output. Basically, the output should be within some range. Okay, it should not be infinite. Then you say that the network is stable, and you saw that how to
By both criteria, sir.
which criteria.
Bibo, sir. Bibo, BIBO,
Huh,
bounded in.
yes, correct. Bounded input, bounded output, yes. So you saw that a network is stable if its transfer function has all poles in the left half plane, right? You saw that. Also, the numerator degree should be less than the denominator. So these two conditions were mentioned for network stability, right?
Yes.
Yeah, fine. So so this is again I have placed here. It was also there in the last week's slide. I have again placed it because we will be solving some problems on Laplace transforms, right? so this might come in handy. So these are the properties of Laplace transform, and here I don't think it is visible, but this table gives some common Laplace transforms. So did you go through, by the way? I post my slides, right? It is accessible through Google Drive. It is accessible through the NPTEL or SWAM platform, whichever you're using. So did you see these things? Have you gone through this?
मैंने पहले याद करके कुछ
Nice, very good, very good. Okay, so let's solve some questions now. Fine. So this is visible, right? The first question
yes
is this one. Suppose that f of t is equal to u of t minus u of t minus 2. Determine f of t convolve with f of t for t between 2 to 4. So let's write this question here. Okay, so I have to change the yeah. So this screen is visible, right? The new screen.
yes
Okay. Okay. So what we have to do here is question is your f of t is what? It's u of t minus u of t minus 2. Fine. And you have to find out f of t convolved with f of t, right? And for what time? T between 2 to 4 seconds, right? So
yes
how should I proceed? Can you tell me? What should I do?
first we draw the graphs means u of t के लिए means
Okay, so
add the
basically you are saying that we should use graphical approach to solve this question, right?
yes yes
Okay, so let me write this here. Method 1, graphical approach. Fine. Okay, let's do that. Okay, so I will draw the f of t here. Okay, so f of t is u of t minus u of t minus 2, right? What is u of t? U of t,
uh, unit impulse signal when t is greater
unit,
than 0
not
value is 1.
units impulse, it is unit step. Okay,
Yes, so yes, unit
yeah,
step.
so this is u of t.
For t greater than 0 value is 1.
Yes, right, correct. And what is u
T
of t minus 2?
shifted of t minus 2.
So
Sh-
it should become 1 from t is equal to 2, right?
Yes.
Right. So this is again 1. Now I am subtracting this from this, right? So u of t minus 2, this is u of t minus 2, this is being subtracted from this particular u of t, right? So what will be the f of t? So f of t should be
Uh,
something of this kind. Yeah,
rectangle,
tell me, how should it be?
rectangle, rectangles pulse 0 to 2.
Yeah, correct. So it is 2, this is t, this is f of t. Fine. I have drawn f of t. Now I have to convolve, right? F of t convolved with f of t. So what is the formula of convolution? How do you find convolution? So if I say f of t is convolved with f of t itself, it means what?
Integration of 0 to infinity, f
Minus
of tau
infinity to infinity, not 0 to infinity.
and f of tau into f of t minus 2.
Yeah, f of tau, f of t minus tau, d tau. Yeah, and this tau limit is from minus infinity to plus infinity. It is 0 to infinity for causal systems where you want to find the impulse response. There it is 0 to infinity, not for convolution is defined as minus infinity to infinity. Okay.
Yes.
Okay, yeah. Now okay, but you are interested here for what? We want to find uh, let's say this is equal to y of t. Okay, so you want to find y of
Yes.
t from t between 2 to 4 seconds, right?
Yes.
So can you tell me what is f of tau? F of tau is same as this, right? So let's quickly draw that here. So you see f of t is equal to 0, f of t is equal to 1 here. Okay. It is equal to 1 from 0 to 2 seconds, and it is 0 elsewhere, right? So let's quickly draw f of tau here. So f of tau, this is f of tau, this is 2 seconds 0, this is tau, this is f of tau. Fine? Yeah.
Yes.
And what is f of t minus tau? How will it look? Sorry. Tell me. How will it look? F of t minus
And
tau.
shift is at t is equal to tau. So,
This is tau, okay? And I want to plot f of t minus tau. How will it look? First, what you have to do? First, you have to find out f of minus tau, right? So f of tau looks like this. F of minus tau will look how? What? How will it look? It will be starting from minus 2, right? Minus
yes.
2 to 0. Correct?
Yes.
And in that you have to shift it again, right, by t. Correct? So it will be how? How will it be? It should be starting from like this. It should be minus t minus 2 plus t to t.
And
Fine?
once again,
Hello?
yes, sir. Once again, I will fix
Yeah,
the
so
t.
okay, so okay.
Also.
So f of tau is this, right? How will you find
Yes.
out f of t minus tau? So f of t minus tau can be written as f of minus of tau minus t, isn't it? This is same as f of t minus tau. Correct?
Ye- Yes.
Yeah, so what is this? What is meant by this? First you have to invert your f of tau. Okay, first you have to find f of minus tau, and after that, that particular f of tau, which that particular signal, you have to shift it to the right by t. Correct? Is this understood?
No, sir.
Okay. Okay. So how will you plot this signal? First you have to plot f of minus tau, isn't it?
Yes, sir.
After that, if you after that you have to shift this. You have to replace tau with tau minus t, right? Isn't it? After this, you have to replace tau by tau minus t, isn't it? If you replace tau by tau minus t, you will get this, isn't it?
Yes.
And this is same as this, correct?
Yes.
So f of minus tau, first you have to find out, which is how f of minus tau is, how will f of minus tau look? It will be starting from minus 2 to 0,
Mine.
right?
Yes.
Okay, so this will be 1, correct? This is f of minus tau,
Mine.
correct? Now you have to replace tau by tau minus t, and replacing a variable by replacing tau by tau minus t, what does it mean? You have to shift the whole graph, this particular graph, this graph here, you have to shift it to the right, isn't it?
Yes.
Correct. So that is what we have done. So if you shift it to the right, then minus 2 will become what? Minus 2 plus t, isn't it? And the next point is 0. This 0 will be shifted to t. Got it?
Yes.
This whole graph here is shifted to the right by t. So minus 2 will be shifted to the right by t, which will, what does this mean? You have to add t to minus 2. Okay. Similarly, 0 will be shifted to 0 plus t, which is equal to t. Now it is understood, right?
Yes.
Okay, fine. So this is your f of t minus tau. So this is the same that I have written here. This is minus 2 plus t. Now they are saying that you have to find out y of t between t is equal to 2 to 4 seconds, right? Now notice that t between 2 to 4, t minus 2, this is what? This is t minus 2, isn't it? So let me write it clearly here again. So your f of, this is tau here, this is f of t minus tau. Okay, so
Yes.
clearly see that this is t minus tau, t minus 2, isn't it? Minus 2 plus t is equal to t minus 2, right? This is t minus 2. This will be greater than 0. This particular point, t minus 2 will be greater than 0 for what? For t greater than 2, isn't it?
Yes.
Now we are interested in our t is what? Ranging from 2 to 4. So t is indeed greater than 2, right? So our this particular point here, my cursor is visible, that the
Yes, sir.
one that I am hovering over t minus 2. Yeah, so this
Yes.
particular point t minus 2, this will be always positive, isn't it? So the graph should look like this for t is equal to 2 to 4 seconds. This particular thing, f of t minus tau, this should look like this. Sorry, this should look something of this kind. So this will be t minus 2 and this will be t. Understood?
Yes.
Yeah. So this will look like this. So if t is equal to 2, then this point here will become 0, isn't it? So now let us do the
Yes.
convolution. So basically you have to what? You have to multiply these two signals now, f of t and f of t multiplied by f of t minus tau, and then integrate it. So you see f of tau multiplied with this particular, this will become what? So you see that so yeah, so for up to t minus 2, up to this time here, this is 0, right? F of t
Yes, sir.
minus tau is 0, but this is non-zero here. But when you multiply both of this will become overall this will become 0, right? Because this is being multiplied by a 0 quantity. So I will plot it like this here. So your signal will become like this. Up to t minus 2, your f of tau multiplied by f of t minus tau will be equal to 0. Okay. Now for between these 2 points, from here to here, this is no this is also equal to 1 and this is also equal to 1, isn't it?
Yes.
Yeah. So these two when multiplied together will become equal to 1, right? So this is
Yes, the
equal to
same.
1 and this
Here
is up
again
to equal to 2, and after that again it will be 0,
0.
correct? Up to t, and further even after t it will be 0 only, right? So it is non-zero only for this period between t minus 2 to 2, correct? So your integral hence your y of t, which is equal to f of t convolved with f of t, will be equal to t minus 2 to 2 seconds integral 1 d tau, correct?
Yes.
Is this understood? I have simply replaced this here with this, correct?
Yes, sir.
Oh yeah, okay, nice. So what will this integral be? Quickly tell me.
Tau means t minus, by tau minus 2 minus 2 means tau.
This will be equal to 2 minus t minus 2, 4 minus t, isn't it?
Yes, sir.
Correct?
Yes.
Yeah. So this is indeed the answer, okay? This is 4 minus t volts. Okay, fine. Now can you do it in another manner? Can you find it using Laplace transforms and all? But this is nice. This is right. This is graphical approach is correct. So let me do it another manner. Okay, I'll write it here. So method 2 using Laplace transform. Okay. Yeah. So the f of t is what? U of t minus u of t minus
You,
2. Correct? And we
yes,
have to find out
Laplace of f of
f of t convolved with f of t. Right? So how will I do this? So you know that suppose if I find out its Laplace transforms f of s, okay, and
yes,
after that what is convolution in the Laplace domain? Convolution is simply replaced by multiplication, right?
yes,
So this will, in that case, this will become simple multiplication into uh, f of s, correct?
yes,
After that, when you basically this will become what? F of s square, right? And after that you can invert it again, Laplace inverse. You can invert it to get your y
f
of
of
t,
yes, right.
right? So yeah, so this is by the way, this is y of t. Okay.
Yes,
So tell me, what is the Laplace transform of this?
1 by s
1 by s minus,
uh, e के power minus 2s.
yes, e to the power minus 2s. No,
E के power minus s मल्टीप्लाई हो जाता है 1 by
correct.
s.
True. Yeah, yeah. So you are right. It is e to the power minus 2s. Fine. So what is
Yes,
this? 1 by s common, 1 minus e to the power minus 2s. Right? So now this is f of s. Now you have to square it, isn't it? You have to multiply f of s into f of s. So what is f of s square? So this will be, by the way, this is y of s is equal to 1 by s square multiplied by 1 minus e to the power minus 4s, sorry, plus minus 2 e to the power minus 2s. Right?
yes,
Fine. So what now, yeah, now let us split each and every term. So this is s square plus 1 by s square e to the power minus 4s minus 2 by s square into e to the power minus 2s. Right?
yes,
So what will be the, now what is the inverse of this? So I also need to find out Laplace inverse, right?
yes.
What will be that?
T by 2 sir.
T by 2. So you know that, yeah. So each and every term you have to take inverse, right? So you have to take inverse of this, and inverse of this. Correct?
Yes,
So what is the inverse of 1 by s square?
T by 2 sir.
It's only t, it's not t by 2.
Yes, it is.
Yeah. Why is it t?
Because कोई भी Laplace का t के power 1 है तो 1 ये 1 factorial by s के power 1 plus 1 means 1 by s square.
Yeah. So it is basically integrated, right? uh, each time you integrate a signal, you multiply 1 by s in the Laplace domain, right? And you know that 1 by s is the Laplace transform of what?
Unit
U of
impulse,
t, right? Unit step.
unit
So
step.
if you take u 1 by s square, so its Laplace should be integral of u of t, and that is simply equal to t. Sorry. This is simply equal to t. Fine. Yeah, so this
मीन्स
is,
जितना बार मल्टीप्लाई होगा उतना बार मेरा इंटीग्रेट
correct. So
होगा.
this is t u of t. Fine. So by the way,
Yes.
there will be u of t also. It will be starting from 0, not before that. Fine. So this is plus 1 by s square. It's again t u of t, but then you have e to the power minus 4s. So what does this mean? You have to shift everything in the time domain, right, by 4 seconds.
Yes.
So it should be t minus 4 multiplied by u of t minus 4. Correct.
Yes. Yes.
Similarly, this will be what? Minus 2 t minus 2 u of t minus 2. Isn't it?
Yes.
2 by s square e to the power minus 2s. 2 will be multiplied here, and e to the power minus 2s, because of that you have minus 2 here, both places. Correct. Okay.
Yes.
So this is
यहाँ
the,
पर
yeah.
एक कंफ्यूज, यहाँ पर 1/s² ई के ई माइनस फोर एस है, तो सबसे पहले तो मैं ई के पावर माइनस फोर एस को करूंगा तो ई ऑफ टी माइनस फोर
नहीं 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 नहीं. If you do
प्लस.
that, you will be in problem. You see, you remember, you know that e to the power minus 4s is there in the Laplace domain, right? So this means
Yes.
that there is definitely some time shift, right? E to the power minus some constant to s comes when you have time shift, right? So you see this here. Why did we write minus 2s here? Because it was time shifted by 2 seconds, right? So
Yes.
we know that u of t, its Laplace transform is 1 by s. But since there was a time shift by 2 seconds, you also multiplied e to the power minus 2s, right? So similarly here also, we know that 1 by s square has a what? It is equal to t into u of t, right? 1 by
Yes.
s square. Now, like here, 1 by s square is t u of t, correct? Now there is a e to the power minus 4s multiplied here, correct? So for that you have to shift it by 4 seconds. Everywhere you have to replace t by t minus 4. Wherever you have t, so this is t u of t, and e to the power minus 4, so you have to replace t everywhere. So here and here, both places you have to replace t by t minus 4. So that is what we have done here. Understood?
सपोज हम लोग सपोज करते हैं 1/s³ है, 1/s³ into e के पावर माइनस फोर, देन हाउ
हाँ, तो 1 by
उसका.
s cube, 1 by s cube, you first have to find out the inverse of 1 by s cube, and then you will get some time domain equation, right? Everywhere that you have t, you replace it by t minus 4. You will get your required Laplace transform in that case, inverse Laplace transform. Understood?
तो मीन्स 1/s³ का मेरा t/2 होगा सर. तो
Okay, one second. 1 by s cube, first you have to find out what is the Laplace transform of 1 by s cube. So what is the Laplace transform of 1 by s cube? You want to find out 1 by
yes.
s cube e to the power minus 4s, right? It's Laplace
Yes.
transform. So let's take a digression here. Let's quickly solve this. Okay, so that your doubt is completely. Let's take a digression. So first you have to find out 1 by s cube. So you know that 1 by s square is t, right? T u of t. So 1 by s
Yes.
cube will be equal to what?
t²/2.
Yeah, so you have to integrate it, right? You have to integrate it between 0 to t, tau u of tau d tau. Fine, you have to integrate it. So what
Yes sir.
will it be? This is tau square by
T
2, so t square by 2 u of t. Fine. This is 1
yes.
by s cube. Now you have to find out, this was the 1 by s cube Laplace inverse. This is Laplace inverse of 1 by s cube. Now you have to find out 1 by s cube e to the power minus 4s. So what you have to do, everywhere that you have t, you replace t by minus t minus 4. So t square here will be t minus 4 whole square by 2 multiplied by u of t minus 4. Understood?
Yes sir, curious.
Okay, so fine. So yeah, I was here, right? Now you see that we want y of t in t between 2 to 4, correct? In this
Yes.
time we require. Now what is u of t minus 4? U of t minus 4 starts becomes non-zero only at 4 seconds, right?
Before geos.
Before it is 0, isn't it?
Yes.
At t is equal to 4 seconds, it becomes non-zero, it becomes 1. So this is u of t minus 4, correct?
Yes.
So you see that this particular term here in the middle one, is my cursor visible?
Yes. Visuals.
Yeah. So this right here, this will become 0 between t is equal to 2 to 4, because before 4 it is 0, right? So in the time that we are required to do it, we are required to find out between t is equal to 2 to 4 seconds. In that time this is not this is equal to 0, right? So this is not at
Yes.
all present. Fine.
Yes.
Yeah, so I will remove this. So our new signal is t of u of t, t into u of t minus 2, t minus 2, u of t minus 2. Fine.
Yes.
Yeah. And between t is equal to 2 to 4, u of t minus 2 and u of t both are equal to 1, isn't it?
Yes.
This is clear, right? Or you want me to explain it? Okay, okay, I will explain it quickly. This is u of t. U of t is equal to, right at 0, isn't it? It will be non-zero starting from 0. From here it will become 1. What
Yes.
is u
You
of
of
t minus 2? U of t minus 2 will be non-zero at t is equal to 2 seconds.
yes means t u of t का value भी 0 होगा sir.
Correct. So between t is equal to 2 to 4 that you are interested in, 2 to 4, both of these are equal to 1, right? Here you see this is also equal to 1, this is also equal to 1.
Yes.
Correct. So you just
Yeah.
have to, yeah, any doubt?
सर लेकिन t into u of t का वैल्यू तो 0 होगा ना, क्योंकि वो t is equal to 0 पर वैल्यू 1 होगा, नहीं हम मुझे 2 to
No,
4
no,
के
no.
बीच में.
I am not interested in t into ut. I am only interested in u of t and u of t minus 2 for now. Okay.
बट u of t का वैल्यू तो उसका भी तो 0 होगा सर.
हाँ हाँ, t is equal to 0 पे just 1 होता है ना ये. It becomes just 1 at t is equal to 0, isn't it?
लेकिन मुझे वैल्यू मतलब मुझे वैल्यू तो निकालना है सर जब t का वैल्यू 2 to 4 सेकंड के
हाँ
बीच
हाँ,
में हो.
राइट. तो
तो फिर
2 to 4 के बीच में
सेकंड
तो नॉन जीरो होगा ना दोनों.
2 to 4 1 ये फर्स्ट टर्म हमारा 0 होगा, लेकिन सेकंड टर्म हमको चाहिए ना सर.
No, no,
So,
I don't know what you are confusing it with. So I am only
but,
right now. Forget about t. Okay, forget about t and t minus 2. I am just interested in u of t and u of t minus 2. Is this clear? Here,
uh,
u of
yes
t and
okay.
u of t minus 2. Is this clear?
Yes, yes
Fine.
okay. Yes.
So u of t is also non-zero between t is equal to 2 to 4. U of t minus 2 is also non-zero between t is equal to 2 to 4 in this range. Correct?
Yes, yes,
Fine.
yes.
So both of these are equal to 1. Non-zero equal to 1. Both of these are equal to 1. Fine.
Yes, okay. Yes.
Okay. So let's replace. So we will replace u of t and u of t minus 2 both by 1. So y of t now is equal to t minus 2 of t minus 2, and this is this u of t is replaced by 1. Here also u of t minus 2 is replaced by 1. Understood?
Yes.
Yeah. So this is clear, right? Till now.
Yes.
Now tell me what is your issue. This is between t is equal to 2 to 4 seconds. Now tell me what is your issue.
नो सर क्लियर हो गया सर,
Oh,
मुझे लगा कि वो 0
okay,
अब
fine,
समझ.
fine, fine. Yeah, so what is this value? This is t minus 2t plus 4. Fine. And this is
4
equal
minus.
to 4 minus t. Fine.
Yes.
So this is what we got earlier also, 4 minus t. You see this is 4 minus t, right? We got it from graphical approach, and we also got it from Laplace transform approach. You see, you are getting the same value, right?
Yes.
Yeah, fine. So this was the first question. So now let's go on to the second question. Okay, wait for a second. Okay, yeah, this is the one. Second question. H of t is 4 e to the power minus 2t u of t. X of t is delta t minus 2 e to the power minus 2t ut. So let's take a screenshot of this. So we have to find this out.
Yes, everyone there is easy.
Yes, of course it is easy. Yeah. But that is why these questions are there, to help you, to make your understanding better.
Yes, easy रहेगा सर Laplace के थ्रू graphical approach में थोड़ा ज़्यादा
Correct. So this is a very important observation that you just made. It's important that you make these observations. So let's solve it. Yeah. So is this screen visible?
Yes, sir, visuals.
Yeah. So let's basically. So we have to find this out, right? So there are two ways in which you can again do it. So let's first go with. Yeah. So there are two ways, right? So method. So one is graphical
Approach.
and second one is what? Second one is Laplace transform using
Laplace.
Laplace transform. So you see how complicated is this signal, right? 4 e to the power minus 2t, 2 e to the power minus 2t, then there is a Dirac delta also. It is very messy. If you use this graphical approach, you will be able to solve it. You will definitely be able to solve it, because graphical approach is also used, and definitely you should get the same answer. But this will become messy, right? The calculation will be very difficult. Okay. So what you
Yes.
should rather do, you should use Laplace transform. It becomes very easy after Laplace transform. Let's quickly do it. So h of t is what? 4 e to the power minus 2t u of t, and x of t is equal to delta of t minus 2 e to the power minus 2t u of t, right? So
Yes.
You have to find out y of t, which is equal to xt convolved with h of t. Fine. So you know that in the Laplace transform domain, what will this be? This is y of s. It will be equal to x of s multiplied by h of s. Correct?
Yes. So then in Laplace inverse.
Yeah, correct. Then we will do simple Laplace inverse. Right. So this is Laplace inverse. Fine. So let's quickly find it out. So what is x of s?
4 by s plus 2.
Eh?
4 by s plus 2.
X of t is
H.
this one, right? So what is x of s?
1 minus 2 by x plus 2.
2 divided by?
S plus 2.
Correct. Very good. Yeah, right. And what is this one? H of t, h of s?
4 by s plus 2.
What is 4 by
S plus
plus
2.
2? Very good, very good, very good. Yeah. Now you have to multiply x of s with h of s. So multiply x of s with h of s. Right. So you get what? Y of s is equal to x of s into h of s, which is equal to 4 by s plus 2 into 1 minus 2 by s plus 2. Correct?
Yes.
So this is equal to 4 by s plus 2 multiplied by s plus 2 minus 2 is again s divided by s plus 2. So this is equal to 4s divided by s plus 2 ka whole square. Correct?
Yes.
I think I have done some mistake here. No,
So
fine.
we just
Yeah, fine. Everything is right, yes. Yeah, what will you do now?
Partial fractions.
Correct. So tell me, what is the partial fraction of this?
A by s plus 2 plus b by s plus 2 का square.
Very good. Nice. What are A and B?
A का वैल्यू 4 से b का वैल्यू -8.
B का value minus.
8 से.
Let's quickly see whether it is right or not. So if A is 4, then basically 4s, this will become what? 4s plus 4 to 8 minus 8 times. This is what it is. Yeah, so yeah, correct. This is indeed correct. Okay.
Yes.
So yes. So what will be the Laplace transform, inverse Laplace now? So this your y of s is equal to 4 divided by s plus 2 minus 8 divided by s plus 2 the whole square. Correct. So what is then sorry, what is the Laplace inverse of this y of
4 into e के पावर -2.
4 by
4 into e के पावर -2.
minus 2 t
t e of t
u of t, very good,
minus
minus
8
8
t
t,
e के पावर -2.
very good, very good, yeah. Indeed, it is correct. So I am very impressed by what you did. So this question I didn't solve anything, I did what you told me. So I the other guys, any other has any problem with this question? The people who are in the meeting, do anyone have any doubt? I
No,
will
sir.
clear it.
Clear, sir. Clear.
Very good. Yeah, so Abhishek, yeah, you are indeed correct, and this is the answer. Fine. So you solved it right now, or you already solved it earlier? Have you seen this question earlier?
नो सर मैं अभी सॉल्व किया
Very
क्वेश्चन
good,
को देख.
very good, very good. I am impressed. Nice. So since you have solved this question, so let's move on to another question now. Okay. Yeah. So this is another question here. Yeah. Let's take a screenshot here also.
दिस इज आल्सो इजी क्वेश्चन.
Yeah. So do it. Yeah. So these questions are easy. If you are finding it easy, then it's good, because then you have understood the question, understood the concepts. So tell
यस
me,
सर.
you have to find the impulse response. What is meant by impulse response? You are given transfer function, right? H of s
मतलब
is equal to,
यस मेरा कोई सिस्टम है सर जो कि ट्रांसफर फंक्शन दिया हुआ है एच ऑफ एस
हाँ,
मीन्स आउटपुट बाय इनपुट और इनपुट मेरा दिया हुआ है सर 1/s लैप्लास में. तो सी ऑफ एस मीन्स मेरा आउटपुट जो होगा मल्टीपल ऑफ एच ऑफ एस इंटू 1/s
no.
जो.
One second, one
यस
second.
मतलब
See,
सर मेरा जो
yeah, okay.
ट्रांसफर.
Let me tell now. Let me speak now. Okay. You see, h of s, it's the what is meant by transfer function? Transfer function is nothing but the Laplace transform of h of t. Okay. So if you what is h of t? What is this? Okay, this is impulse response. Okay. So if you denote impulse response in general with h of t. Okay. This is the general notation of impulse response. So impulse response is h of t, and its Laplace transform is h of s, which is also called the transfer function of the system. Understood?
सर मैं ये बोल रहा था सर कि जैसे मेरा कोई सिस्टम है सपोज करते हैं जी ऑफ एस.
ओके.
वो सिस्टम का मेरा कोई इनपुट दिया हुआ है, इम्पल्स दिया मीन्स 1/s दिया हुआ है.
Impulse is not 1 by s, that is unit step. Unit step is 1 by s.
Yes, yes,
Impulse is
impulse means
1.
1. Yes, 1.
Delta t is Laplace
1.
is 1. Okay.
Yes, sir. तो मेरा जो आउटपुट रिस्पॉन्स जो आएगा एच ऑफ एस इंटू वन.
Yeah,
मतलब
right. Correct.
डायरेक्ट फर्स्ट डायरेक्ट यस सॉल्व कर रहे हैं लैप्लास सिंबल.
Correct. So this is what is impulse response h of t. Its Laplace transform is h of s. Okay.
यस.
Fine. So here what you have to find out. You are given transfer function h of s. Find the impulse response of the system. So you are given this h of s. You have to find h of t. So what do you need to do?
सिंपली लैप्लास
Partial
इनवर्स
fractions.
Yeah, very good. Yes.
फ्रैक्शन कर.
Correct. Correct.
यस.
So you are given h of s. So h of s can be rewritten as a by s plus 1 plus b by s plus 2, isn't it?
यस.
So tell me what will be the values of a and b.
ए का वैल्यू -1 से बी का वैल्यू 2 से.
Minus 1 by s plus 1 plus 2 by s plus 2.
Yes.
Yes, it is right. Fine. Now what will be the Laplace inverse of this?
-1 e के पावर -1 u ऑफ दिस इंटू e के पावर -30.
Right.
यस.
Plus 2
2 इंटू
e to the
e
power
के
minus
पावर
2t
u ऑफ t.
u of t. So let me write clearly. So it will be what? It will be 2
e.
e to the power minus 2t minus e to the power minus t u of t. Correct?
Yes.
So this is indeed the answer of this question also. So for the first time it has yeah, this is the answer, right?
Yes.
Yeah, so for the first time I have completed all the questions within time.
Yes.
So this is the only 3 questions I had to discuss today. So it's good that you are understanding and you are able to follow these questions. It's very good. So yeah, so if you want to practice more, you can definitely consult the reference that is given in the course website. Basically on the platform there are some of the references are mentioned, right? So there you can definitely try these questions. You can also find a lot of questions on Laplace transform in the very classical very famous book of this one, Oppenheim. Have you heard this name, Oppenheim? Signals and Systems by Oppenheim.
No.
Fine. So this is also a very nice book. So there also you will have a lot
Signal
of
and system.
questions. Yeah, Signals and Systems by Oppenheim, Alan V. Oppenheim.
Okay.
Okay, so there also you have a lot of questions. So you can definitely try them out. Okay. So if you have no other doubt, then we can end this session here. If you have any doubt, you can ask me. So I just
सर
this 3 questions.
हम लोग सुपर पोजिशन थ्योरम में ये पढ़े कि एक बार में एक ही सोर्स लगा है. तो
हाँ.
हम एक बार में सपोज करते हैं कि एक सर्किट है सर जिसमें 2 वोल्टेज सोर्स है, एक करंट सोर्स है.
Okay, so let me.
इंडि इंडि
Yeah, yeah. So it will be better if I take open my notebook. Okay, so let's listen to your question. Yeah. So tell me what you have, what doubt you have.
ये क्वेश्चन ये है कि एक सर्किट है जिसमें मेरा 2 वोल्टेज सोर्स है, एक करंट सोर्स है
Okay,
और
there are one current source. Okay,
एंड 2 वोल्ट एंड
two
2 वोल्टेज
voltage
सोर्स.
source.
यस. लेकिन सुपर पोजिशन थ्योरम बोलता है ऐसे कि एक बार में एक ही सोर्स लेके चलना है और करंट सोर्स को ओपन करना है और वोल्टेज सोर्स को शॉर्ट करना है.
Right. True.
लेकिन हम ऐसे लेके चल सकते हैं, सिर्फ करंट सोर्स को लेके चलना है, दोनों मतलब एक बार में दोनों वोल्टेज सोर्स को लेके चल रहे हैं, करंट को ओपन कर दे रहे हैं, ऐसे कर
हाँ,
सकते हैं.
कोई दिक्कत नहीं है. बस उस केस में फिर 2 ही बार इक्वेशन लिखना होगा, 2 ही बार सॉल्व करना होगा सर्किट को. Yeah, you can
O-
definitely do that.
Okay.
There is no issue.
Okay.
Yeah, so this is a general argument, right? So either you solve. So what is superposition? You take one source at a time, right, and then you add the response due to all the sources individually.
लेकिन हम लोग यहाँ पर एक बार में 2 सोर्स लेके चल सकते हैं? कोई ज़रूरी नहीं है दोनों वोल्टेज सोर्स ही हो सर। एक बार में मान सपोज़
Ah,
कर
so that is what I'm coming to. Okay, so what I'm saying is that what is superposition? Superposition, you have superposition says that you have to take each of the source one at a time, and you have to find the response due to each of the sources. Basically, you find V out here due to each of the sources, and then you add them, right? You add them algebraically. So this is what is superposition. But superposition is not limited to individual application. Okay, you could have also done what? You could have also taken these two sources one at a time, and this one at a time. So what you could have done is that you take these two sources and you short this voltage source here and find out what is the voltage. Then in the next time, what you do, you short this and you open this and take this voltage source, and then you find out the voltage, and then you add these two voltages algebraically. That also you could have done. Okay.
Yes. Okay. Yes.
So in that case, you will only have to solve two times. Okay. Normally, for this circuit, if you apply superposition in the conventional manner, you have to solve it three times. The circuit, isn't isn't it?
Yes. Yes.
Each source at a time. But if you do it another manner, that you take two sources at a time, then you can get away with only two times of circuit analysis. Okay,
Yes.
fine. Anything else?
Yes.
Okay. Anyone else? Anything else? The other people who are in the meeting. Any doubt?
एक और जो ग्राफिकल अप्रोच है उसमें थोड़ा दिक्कत होता है सर, जैसे लैप्लास के थ्रू तो वो तो इजी टू निकल जाता है,
Okay.
लेकिन ग्राफिकल एनालिसिस में थोड़ा प्रॉब्लम होती है।
It's
वो
nothing.
कैसे?
It's very simple. You have to. So first thing is that graphical approach is not something which you will be using, you will be solving in general. In general, it is Laplace transform which is favored because it is easy, right? Graphical approach is it can be easier if your signals are very simple, like in this case. You see, it is very simple here, right?
ये तो सिंपल था, ये तो अच्छा है।
So in that case, your graphical approach is also easy. But in general, your Laplace transform is the easiest one to do to go ahead. Okay. So for graphical approach, you don't have to do anything. You have to just apply you have to just simply add the signals in the manner that they are added. They are supposed to be added. Okay, just the way that I did here. You first found out what is f of t, then you did your this. Basically, you have to realize this particular convolution, right? This is f of tau into f of t minus tau. So f of tau you already have because you have f of t. Then you have to find out f of t minus tau. So what is that? That is invert and then shift, right? Take the mirror
Yes.
image across y axis and then shift in the time. Shift to the right. So this is what we did, and then we solved it. So solve some examples. Okay, solve your assignment also. You can find examples on this in the same book that I said, Alan V. Oppenheim, Signals and Systems. In that there is a second chapter. Okay, LTI systems. There you have plenty of examples on convolution that you can solve if you want to. You can also
Okay.
solve the second question that you solved using Laplace transform here. The second question, where is the one? Yeah, the second question we solved using Laplace transform. Like, you could also go through graphical approach. You can see that you will be able to solve it using graphical approach also. Okay,
Yes.
try it out and see whether your answer matches or not. Okay, solve some examples
Okay.
and you will have confidence. Fine. Anything
Okay.
else?
No.
Fine. So let's end it here in that case. So thank you for joining today. I hope you will
Thank
join the
you.
next session also. Okay.
Yes. Okay.